Welcome, Hamilton students. I'm going to talk about real quickly the quotient rule for logarithms. We've gone over how to change the standard form into logarithmic form. We have discussed the product rule for logarithms, so at the very least I'm going to try and get the quotient rule for logarithms up. If you look up here in the top right hand corner, I've written the actual exponents and the two different forms that we're going to use. We've got 2 to the 6, which is 64. Can also be seen in logarithmic form right here. Log base 2, 64 is 6, and 2 squared is 4, and you can see the logarithmic form over here. And you'll probably get tired of hearing me say this, but as you can see, this entire side of log base 2, 4 is a log. Is an exponent up here. So this really equals that exponent, which if you keep that in mind as we look at the quotient rule, it might make it seem a little bit easier to you. So here's a standard kind of formula for the quotient rule for logarithms. You can see that any log with a base in which a quotient or a division problem is being done can be written as, well, those two logs are subtracted from each other, the difference of those two logs. And if you really think about it, if you look over here, we got 2 to the 6th power divided by 2 squared. What you're really doing when you're dividing exponents is you're keeping the base and you're subtracting. 6 minus 2 is 4. Well, seen over here, what you're really doing, right, when you're doing a logarithm of a quotient, and again, we're subtracting, and it'd probably be a little bit easier if I actually use numbers. So we're going to use those numbers that we've been dealing with already. I'm going to write over here, let me get a pencil, I'm going to write log base 2, and I'm going to try to show this right here. I'm gonna deal with a 6 up here, and in order to make a 6, I'm going to have to come over here. I'm going to say, 2 to the 6th power, which is 64, and I'm going to deal with this exponent of 2 right here, which we know is 4. This should equal log base 2 of 64 minus log base 2 of 4. Now this really is, right here, this is the exponent 6, right? 2 to the 6th power is 64, so this entire thing is equal to the exponent of 6, and this entire thing right here is equal to the exponent of 2. So the concept behind it is if I'm doing a logarithm of two different exponents, right? Log base 2 of 64 is the exponent 6, log base 2 of the exponent of 4 is the exponent 2. So by doing this, I am showing that dividing exponents, right, with the same base is the same as subtracting, which we can see over here. So let's go ahead and do this. We're going to say log base 2, and 64 divided by 4 is 16. We'll say that is equal to log base 2 of 64 minus log base 2 of 4, right? And again, I'm just going to show you that this works. Alright, 2 goes into the, well, if I 2 to the what power is 16, and that would be 2 to the 4th, right? Show you a little, mark it as I count. 2, 4, 8, 16. Alright, this should be equal to 2 to the what power is 64. Let's do it again. We got 2, 4, 8, 16, 32, and 64. Alright, so that should be equal to 6 minus, hey, well, we know 2 to the 2nd power. So this is 4 equals 4. That's just kind of showing that this rule that we're talking about works. So again, the quotient rule for logarithms can be used to either expand the logarithm of a quotient, or conversely, you could say, hey, you know what? I'm subtracting 2 logs, and that would say I can put them together and do the logarithm of a quotient instead. I hope this has been helpful, and make sure that you do your homework.